Welcome to Chibuzo Mathematics and Physics.com. I will be showing you how to find the limit of a function using the first principle. If you are new to this channel, you're welcome. Kindly subscribe. Now the question is derivative by the use of limit. Derivative by the use of limit. If you don't understand what is derivative, I will ask you to start from the first video that I have already made about what is meant by the derivative before you proceed to this video that I'm going to do now about the first principle. Now, when you are asked to find a limit of a function, it is given, the formula is given as f prime of x is equals to the limit of that function as h approaches 0 of f of x plus h minus f of x. All this divided by h. So this is just the formula that we have to use in order to find the limit of a function using the first principle. So let us jump into it. Assuming that you are given, you are asked to find the derivative using the first principle. Of a function, and what is the function? F of x is equals to 2x, or let us take x squared. So the question is find the derivative using the first principle of a function f of x is equals to x squared. So what is our f prime of x? F prime of x, we know that it is the limit as h approaches 0 of f of x plus h minus f of x, all this divided by h. Now, using the limit, we are going to plug in our function f of x is x squared. So when we see x, we just need to put x plus h, x plus h. That is the function. So we have the limit as h approaches 0 of x plus h, but here it is squared, minus f of x. What is our x? It is x squared. All this divided by h. So from here you will open up the bracket so that you have the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared, all divided by h. What we have done is to open this bracket. We have expanded the bracket, so where you have x squared, this is 2, binomial, so you have 2xh. Remember, the x is reducing while the h is increasing. That's why we have h and we have h squared. So now you will have the limit as h approaches 0. Now remember we have x squared, so this will go, so that we are left with 2xh plus h squared divided by h. If you look at it, when you observe what we have, you can actually see that h is common, so we can factor h out, so that we have the limit as h approaches 0, we put h to x plus h. All this divided by h. We are trying to factor h out so that we can divide h by h, and we are left with the limit as h approaches 0 to x plus h. So now you can do direct substitution. Direct substitution is where you see h, you put 0, because the say that h tend to 0. So we have it is equals to 2x plus 0. So our final answer is 2x, and this is the answer. It is very easy and simple once you grasp the concept of finding the limit using the first principle. In my next video, I am going to show you how to find the derivative of a function that is using the first principle, but then maybe cube root. You have x power 3, you have x power 3, x power 4, x power 5, and so on. It depends on the one you were given. If you have something like this, you are going to apply the Pascal triangle in order to expand the bracket. So I will show you that in our next video. But before you go, kindly listen, you can as well use direct computation to find this limit. Direct computation. Direct computation, you don't have to use this formula, f of x is x plus h minus f of x divided by h. No, you have to use another formula that says that x power exponent n minus 1, which means what you have exponent will be multiplied by the base, so that here you have x squared, it will be x, which is 2 times what is here. X is equal to 1, so it is 2 times 1, which is 2, and we are left with x. And 2 minus 1 is just 1, so it is 2x, which is our answer. So you can actually use this method. It is easier, but it depends on the instructions and what you are asked to do. If you are asked to find the derivative using the first principle, this is the first principle. If you are asked to find the derivative by direct computation, then you use that method. See you in our next video, and don't forget, subscribe. God bless you.